continue with the structure of indomethacin, structure and actions. As I've already said, it contains a benzoylated indonitrogen. By saying benzoylated, look at your structure again. This is why we are saying benzoylated. This is a benzoyl group. Benzoyl, because it is to be a benzyl if we did not have this group. But because of the carbonyl group, we call it benzoyl. So benzoylated endonucleus. I hope you understand. It has a benzoylated endonucleus. Sorry. The methyl group at the position 2 of the endo ring prevents free rotation. That we already mentioned. That methyl group does not allow that free rotation around the carbon nitrogen. It pushes the benzoyl group to the cis and keeps the two aromatic rings in correct relationship for COX binding and therapeutic activity. Indomethacin, of course, is a selective, or it's a non-selective COX-1. It's a non-selective COX inhibitor, non-selective COX inhibitor, because it will block both COX-1 and COX-2. Then replacement of the carboxyl group with other acidic. So now we are still looking at SAR. Replacement of the carboxyl group with other acidic functionalities decreases activity. That we have said severally. That carboxylic group is the one which is responsible for optimal activity. For the phenamates, we did see you can replace the tetrazole with retention of activity. Anti-inflammatory activity generally increases as the acidity of the carboxyl group increases, and decreases as the acidity decreases. Of course, once you increase acidity, you increase activity, but remember, you also will increase toxicity. So acidity of usually you increase acidity of the compound by attaching electron withdrawing groups. But of course, increase in acidity also means increase in toxicity. Amide analogs are inactive. Amide means the carboxylic acid is into an amide. Again, remember, amides are stabilized by resonance, not easily hydrolyzed, and therefore will not readily give us the carboxylic group. Acylation of the indonitrogen with aliphatic carboxylic acids or aryl acyl carboxylic acid results in amide derivatives that are less active than those derived from benzoic acid. That is just explaining to us why the benzoic acid. Why the benzoic acid? And all we are saying, if you see, this is for this amide is, of course, reaction between the nitrogen in a carboxylic group. They are only saying when you have aromatic aryl carboxylic acid, they are responsible for maximum activity, and that is why this group is a benzoyl group. Unlike if you put an aliphatic carboxylic group, it's like CH3CH2COH or aryl or aryl acyl. Aryl acyl means you have an aromatic group and then you have a CH2COH. So the best here, there is the reason why we have a benzoyl group at this position and not an aliphatic carboxylic acid or an aryl acyl carboxylic acid is because it was found that the the aromatic carboxylic acids are responsible for maximum activity. So that is just explaining the reason why we have the benzoyl group in place of any other carboxylic acid. Then N-benzoyl derivative substituted the. Again, if you look at our drug, we're only explaining why is the substitution of indomethacin the best. So again, this substituent must be at the para position. You change that substitution from the para position, again, you will destroy activity. This group can either be a fluoro group or it can be a chloro group with, or even a trifluoro group with retention of activity. So that's all we are saying, that that group there, can I go back? Substituted in the para position with fluoro, chloro, trifluoromethyl, or even thiamethyl. Thiamethyl is SCH3 groups are the most active. So you can either put a fluoro, you can put a chloro, trifluoromethyl, or thiamethyl. And of course, remember, these groups must be in the para position. The 5 position of the endo ring is most flexible with regard to the nature of substituents that enhance activity. All we are saying is that at that position, you can put different groups. Like if you look at indomethacin, you have a methoxy group at that. Sulidac. Look at Sulidac. you have a fluoro group at that position. So again, we are saying that this position here can have different substituents and it will still allow for activity. So that position there is, we are saying, is the most flexible. It can allow for different substituents with maximum activity. So you can see methoxy, fluoro, dimethylamino. None of these groups is new to us now. I believe the structure of methoxy, fluoro, dimethylamino, methyl, allelocoxy. Allelocoxy means it is an allyl group which is usually a CH3 CH double bond CH2 and then with an oxygen, and as acetyl are more active than the unsubstituted indorine. But you can't see more often than not for the drugs that we have. Mainly, what they mainly have is methoxy found in indomethacin, and the fluoro is found in the Solidarc. So although sometimes you do have so many groups that are active, normally you go for the best one, that which will give best activity, and of course also the one that would give minimum toxicity. The presence of an indorine nitrogen is not essential for activity. Why? Why is the presence? Why is the presence? Why are we saying the presence of the indonitrogen is not necessary? Can I get an answer? Why are we saying the presence of the indonitrogen is not necessary for activity? Can I get an answer, class? Why the statement that the presence of the indonitrogen is not necessary for activity? Class, please. Students, can we talk? Can we communicate on the public chat? We are saying that the indonitrogen is not necessary for activity. Why are we saying that, or what is the proof that the indonitrogen is not necessary for activity? Why are we saying it's not necessary? Class, please, class. Can I get some answer? Can I get some answer, class? We are saying the indonitrogen is not necessary for activity. Well, muko mekimya sana. No, I can't get any communication, class. I need you to talk something. Say something. Say something, students, please. That class I don't have, just Nyabuto. Nyabuto, thank you. I have many students, unless if you have logged in and left. I need communication from you students. Can you communicate? You never say anything. You just come in and keep quiet. It's not right. You need to try, students. You need to try. Oh, we are here. Newton, we are here. Yes, I'm worried because you are quiet. Newton, tell me something. Give me an answer. I'm worried you are quiet. Learning is two-way communication, interaction. Yes, we are understanding. And to tell me, to prove to me you are understanding, you need to give me some answers. It's not a criminal offense not to get the answer. You are trying. It's better to try, get it wrong. Next time you not get it wrong. Thank you. I can see many of you communicating. Don't worry about not getting it right. Very good. Good, Hilda, good. I'll watch. Newton, I'm still waiting for your answer. I haven't got any answer from you. Joanne, carbon separation between the first hydrophobic ring. That first separation has nothing to do with the nitrogen. That separation is on the other side. We are talking about the indoor nitrogen. I have said it is not necessary for activity. I didn't finish the statement. I'm asking what is the proof that it's not necessary. So let me not take any more of your time. But I need you students. I've got many of you I can see. I have Brenda Chemtai, Choge, Daisy, Evans, Marwa, Frida. I think I'll be calling you by name to answer the questions. Because you do need to prove you are there. Or you do need to try. Anyway, all we are saying, look at the structure of Solidac. You have the printout. If you look at the structure of Solidac does not have an indoor ring. It does not, it's not even like the pyrrole. It does not have a nitrogen at that position, and yet it has activity. And that's why we are saying that implies that the indoor nitrogen is not necessary for activity. It can be replaced. We call it an sp2 carbon. It can be replaced with an sp2 carbon. That's a carbon double bond with retention of activity. And that you can see from the structure of, you can see that from the structure of Solidac. So we are saying the presence of the indoor ring nitrogen is not essential for activity. But of course, when it is there, like in indomethacin, it is necessary for activity. When it is there, like if you're discussing again the SAR of indomethacin, you will say, for that indomethacin, the nitrogen is necessary. But now when you're talking about the general SAR of those drugs, you can be able to say that it is not necessary. It can be replaced. That indoor ring can be replaced with the benzyl indene analogs like Solidac with retention of activity. So that's why we are saying it is not necessary, because indeed if it was necessary, you cannot replace it. And that is like what we said of the phenamate. If you look, you realize we said that amino group, you cannot remove it. And indeed it is all, the drugs in the phenamate, it has to be retained. But for the indoor acetic acid derivatives, you can replace it so that you have the benzyl indene group with retention of activity. Archaeo groups, especially methyl at the alpha position, are more active than aryl substituents. This we had mentioned. The alpha position, you cannot. Archaeal groups, especially methyl at the alpha position, are more active than aryl substituents. Again, therefore, at position number 2, again, you cannot put big groups. You can only put very small groups. Substitution of a methyl group at the alpha position of the acetic acid side chain to give the corresponding propionic acid derivative leads to equipotent or equiactive. And this is the difference. This is the difference between the acetic acid derivatives and the propionic acid derivatives. All we are saying, you can see this is a methylene group. So you can replace one of these hydrogens, one of these hydrogens with a methyl groups. But we are saying for it to qualify to be an acetic acid derivative, even when you replace one of those hydrogens with a methyl group to get a chiral center, to get activity, to get some stereochemistry there, the resultant isomers will be equipotent, will have the same equal activity, meaning that drug is an acetic acid derivative. If it's a propionic acid derivative, then you see that once you replace one of those hydrogens with a methyl group, there will be chirality, like in ibuprofen, and one isomer will have more activity than the other isomer. And more often than not always, but more often than not, the S isomer for propionic acid derivatives activity. But for the acetic acid derivatives, even when you do substitution, where you get chirality, you find that the resultant compounds are equiactive, analogs, or equipotent. The resulting chirality introduced in the molecules is only important only when you have propionic acid derivatives. This anti-inflammatory activity is displayed. This is for only, as I have said, propionic acid derivatives. For acetic acid derivatives, as we have said, the resultant molecules will be equipotent. The conformation of indomethacin appears to play a crucial role in its anti-inflammatory activity. Of course, the conformation is necessary. Remember, we say Sorry again. I'm using Zuku. Mine it's a bit unstable, but for you try and look for a makeup. So it's back again. It keeps disappearing. As I said, I'm not in my house. I'm in my neighbor's house. So it's a kind gesture. So we will take it the way it is, and see what we'll do. So we were looking at the preferred. This we had already discussed that usually when the benzoyl group is in the cis to the methoxy group, then we do have maximum activity. We had also mentioned that the hydrogens at position 2 and position 7 are responsible for pushing these two rings out of planarity. Again, remember, we require this kind of structure because it resembles the arachidonic, it resembles the structure of arachidonic acid, and because these two drugs are competing, these two compounds are competing for the same site on the COX enzyme, they must have structural similarities and also some structural differences because is an antagonist and the other one is an agonist. So this is what we are looking at. We are saying because of this double bond here, it allows us to have the cis-like and the trans-like. And this cis-like structure is what we require for activity. That cis-like structure for indomethacin is what is required for activity. Aqueous solutions of indomethacin are not stable because of the ease of hydrolysis of the parachlorobenzoyl group, so readily hydrolyzed and removed as because you've been left to the amine. It also is a more potent antipyretic than either aspirin or acetaminophen and possesses approximately 10 times the analgesic activity. So it's more potent. We can't be able to explain the increased potency. Aspirin has only one hydrophobic area. Indomethacin has two hydrophobic area. Its structure also allows for the conformational arrangement so that the molecule can be able to bind the receptor appropriately to give us optimal activity. So we understand why this molecule has better activity than aspirin. But however, it do have, of course, toxicity. It is an acid, and therefore it will cause a lot of gastric irritation. So the next from indomethacin is sulidac. And we can note that indomethacin has significant CNS side effects due to the indole ring. Remember, the indole nucleus is borrowed. The indole nucleus is borrowed from serotonin. So this drug can be able to penetrate livers and, of course, bring about CNS toxicity. Thus, the heterocyclic nitrogen was removed and a double bond introduced, giving the indene derivative to try and minimize or reduce all the toxicity. The Z isomer is active, lacks the CNS side effect. The Z isomer, remember, also is the cis, has a cis conformation, lacks the CNS side effect, and causes less GI irritation, but it has low water solubility. All we are saying for this particular derivative, it is a derivative of indomethacin, where all we have done is remove the indole nitrogen and put a double bond. If the whole structure remained the same, that derivative of indomethacin had lesser CNS toxicity, but it had lower water solubility. Of course, also lower water solubility is usually a challenge because of excretion. It can be responsible for crystalluria, because when you have a drug that has very low water solubility, when it's being excreted, there is a possibility of it precipitating within the bringing, of course, crystalluria. Therefore, there was need to change that structure. That is the structure of the indene structural analog of indomethacin. There was need to change it so that we make a molecule which has better water solubility. So what they do? They did introduction of a fluoro group. So in place of the methoxy group at position 5, they put a fluoro group and a methyl sulfonyl group at position numbers, methyl sulfonyl group in place of the halogen, and sorry, instead of the place of the chloro group on the benzoyl moiety. Again, still para to that position, this increased lipid solubility while still retaining activity. So it increased lipid solubility while still retaining activity. But of importance to note is that this drug, it has higher lipid solubility, so it will penetrate the membranes much better, but it is a prodrug. In the body, it is going to be metabolized. Sulidac is a prodrug. Its active form is a sulfide metabolite. supply, allowing for BID, and the thinner is out of plane. Again, the same things that we have talked about. So if we look at that compound, this is what we are talking about. This is our idine analog. That group there and that group is the same. The only thing that we have changed is that, and that drug was found to have much more issues in terms of water solubility. So it was changed to get Sulidac, and once it was changed to have Sulidac, that this group now, compared this group, there was, of course, increased lipid solubility, but there was also an improvement of water solubility, and therefore this drug was much better. But we're also saying this drug, this drug is a prodrug, and in the body, it is metabolized through reduction. So the sulfide of the Sulidac is what we have as our active drug. So all we have said is that this molecule was not good enough because of what crystalluria changed to Sulidac, and therefore Sulidac being a prodrug and in the body metabolized to give us what we require for activity. And of course, because it is a prodrug, what would be the advantage of Sulidac over indomethacin by the virtue of the fact that it is a prodrug? What advantage would you imagine, or do you think what, or in the stomach, what advantage would it have over indomethacin because it's a prodrug? What advantage would you expect it to have? Class, I'm asking, you're saying Sulidac is a prodrug. So what advantage would it have over indomethacin in the stomach? Less GIT irritation, less reduced GIT toxicity. It's important to mention, why would it have less GIT irritation? It won't be hydrolyzed in the stomach, really. Hydrolysis that I don't agree with. The first two, for Choge and Cherotich, they are closer, but I need more details.
Thank you. Thank you.
Oh, sorry. Sorry, I'd put it over. I was talking to myself. So I'm saying Cherotich, Hilda, the answers are correct, but very vague, very summarized. So make sure when you give an answer, let it be a complete answer. Say, yes, it has less GIT irritation. Why? Because it is not active in the stomach. It will not block the institutive COX-1 enzyme within the stomach, and even the constitutive COX-2 within the stomach, and therefore will not bring toxicity within the stomach, lesser GIT irritation. So let us move on.